Hello and welcome back. Hopefully now you can actually see the video and everything I'm writing. I'll write in pen today so it's easier and I got better lighting. So go ahead and start your warm-ups. So we have 3 to the 5th over 3 squared, 3 to the 5th over 3 cubed, 3 to the 5th over 3 to the 4th, and 3 to the 5th over 3 to the 5th. This one will be a little new to you today, and that's what we're going to talk about. So go ahead and pause if you need to finish. I'm going to continue on the notes though. So day 1, we're going to learn about what's called zero exponents. If you look up at the warm-up example, 3 to the 5th over 3 to the 5th, you still follow your quotient rule, which if some of you probably did this, you did 5 and 5. So you subtracted them, so 3 to the 5 minus 5, which is 3 to the 0. Okay, but you don't know quite what that equals yet. So I'm going to show you the original way that I taught you how to do this. So 3 to the 5th over 3 to the 5th is really equal to 3 times 3 times 3 times 3 times 3, right? That's what 3 to the 5th stands for. Whoops. And then again on the bottom, it's 3 times 3 times 3 times 3 times 3. And we talked that 3 over 3 is really 1, so that cancels to be 1. Then this one cancels to be 1. Then this set cancels to be 1, and again and again. Okay. So 1 times 1 times 1 times 1 times 1 is still just 1. So these two are equivalent, so that must mean that 3 to the 0 is equivalent to 1. So what do you think will happen when something else is to the 0 power? Well, what's going to happen is the same thing that happened with our 3. It's always going to be 1. So anything to the 0 power is 1. So if I look at an example here, 4 to the 0 is equal to 1. 1,000 to the 0 is equal to 1. And even variables, x to the 0 is equal to 1. Okay. So anytime you see a 0 power, whatever that piece is just equal to 1. Okay. So here is your definition. A non-zero number. So that just means you can't have 0 to the 0 power. We don't know how to deal with that yet. So a non-zero number raised to the 0 power is equal to 1. And the fancy math definition is a to the 0 equals 1, where a is not equal to 0. So that just means this base number here, whoops, you guys can't see that very well. This base number here just cannot be equal to 0. Okay, so this is just the very mathematical term, the general terminology for what we're doing here today. So now we've learned about the power property, the quotient property, the power of a power property, and the 0 property. So we can start combining those properties together just like we've done in some of these other sections. So I'm going to switch back to my black pen here. Alright. So, sorry guys, I'm trying to move some things around. So simplify and evaluate. So if I look at the example, 7 cubed times 7 to the 0. Okay. Anytime I see something to the 0 power, I'm going to write it as 1 first. So this is really 7 cubed times 1. Okay. And then 7 cubed times 1 is just 7 cubed, which you all know is 7 times 7 times 7. And since it says evaluate, I want an actual number answer. So 7 times 7 times 7 is 343. Okay, so I dealt with my 0 power first, and then dealt with everything else that I knew about. Okay. Here's a little more complicated example of something. So it's 1 times 10 squared plus 2 times 10 to the first power plus 3 times 10 to the 0 power. Okay. So again, the first thing I'm going to deal with is this 0 power here. So I'm going to rewrite everything. 1 times 10 squared plus 2 times 10 plus 3 times 10 to the 0 becomes 1. Okay. Now I can deal with some things straight across. So 1 times 10 squared is still just 10 squared. Plus 2 times 10, because 10 to the 1 is just 10, so I just wrote it as 10. 2 times 10 gives me 20. Plus 3 times 1 is 3. And then 10 squared here. Sorry, I can't move my paper up very easily. I gotta move that thing. There we go. 10 squared gives me 100, because that's 10 times 10. Plus 20 plus 3. And if I add all three of these numbers, I get 123. And again, because it says evaluate, I wanted to get a final number answer. So that, some of you guys will skip from here to here, and that's fine. Okay, but that's one way that you can look at that problem. So there was lots, there was some multiplication, there was some adding, we had different exponent powers that we had to deal with. So it was a good problem to go through. Go ahead and pause it if you need to catch up here. You should pause it anytime you need to catch up. So here's another example. 4 squared times 4 to the 6th over 4 to the 8th. Okay. So again, whenever I'm dealing with a fraction, I'm going to deal with everything on my top first. Okay. So this is an arrow, not an equal 7, just so you know. So 4 squared times 4 to the 6th, these are the same base. So I add my exponents. Remember this from our first part of our chapter. So that's 4 to the 2 plus 6, which is really 4 to the 8th. And 4 to the 8th on the bottom, there's nothing to combine it with, so it's just going to come along for the ride. Now I have division with the same base, so I can subtract my exponents. Again, some of you aren't going to actually write that step down, but I'm writing it to show my work. So I get 4 to the 0, and as we discussed, any number that's non-zero to the 0 power gives me 1. So there's that example for you. So I have one more example. I have one with some variables in it. So I have a to the 4th divided by a to the 0 times a cubed. Now as soon as I see this division sign, I'm just thinking I'm going to put it in as a fraction. So I'm going to write this as a to the 4th over a to the 0 times a cubed. Okay. Now again, as soon as I see this a to the 0, I know that's going to equal 1. So I now have a to the 4th over 1 times a cubed. And a to the 4th over 1 is just a to the 4th. Okay. Anytime you have 1 in the denominator, it's just that top numerator. Okay. Now I have the same bases being multiplied, so I add my exponents. So 4 plus 3, which would give me a to the 7th. Again, if you're not writing the step, if you can jump from here to here, that is absolutely fine. Okay. And this will be our final answer here. Since I don't know what a is, I can't get a final number answer. Okay. So that's it for today's lesson. Here's the homework. Actually, I want you guys to try one on your own. So go ahead and try 6 squared times 6 to the 5th over 6 to the 7th. So you should pause it right here. This is your exit slip. So when I look at your notes, this is how I'm going to grade them. If you haven't done this problem in the warm-ups and written the notes, then you're not going to get credit for the notes. Okay? So go ahead and pause and do your exit slip, and then I'm going to write the homework numbers down here for you. But this will also be on Google and RunWeb. So it's on page 46. Numbers 1 through 5 odd, number 9, 15, and 17. So, good luck and have a great day.